1, 2. Bonsoir et bienvenue. Je ne sais pas si vous m'entendez bien. Ouais, super, parfait. Oui, je viens de dire. Elle me dit c'est en anglais, donc j'explique d'abord que donc bienvenue pour notre meetup et merci à notre host Algolia et Leaseweb. Donc comme on a cité sur le site, le meetup ça va être en anglais. Donc là j'explique seulement le contexte parce qu'on a les speakers qui sont des anglophones, enfin qui ne parlent pas français. Du coup tout le meetup sera en anglais. Et là je suis en anglais. So thank you for coming and thanks to our special guest hosts, so Leaseweb and Algolia. So for this meetup, we will have 3 meetups in one. So I will introduce the speakers. We have Pierre Padrixe. I don't know if he's here. Yes. This is our first speaker. He's French, by the way, but he's going to speak in English. Our second speaker is Anthony Seure. Yes, he's behind. And the third one is Nico Di Rocco. All right, that's fine. So we'll start the meetup now, and we invite Pierre, and enjoy the meetup. Thank you very much.
Hello everyone, so I'm Pierre Padrixe. I'm a Devops engineer at Linkfluence. So I'm going to show you how we process rolling upgrade with no downtime. So firstly, I will introduce Linkfluence, what is our business, what we do, and what is our infrastructure. So we'll see why we are deployed on multiple cloud providers, how we manage to be deployed on multiple cloud providers, how we have cloud agnostic playbooks, Ansible playbooks, and stuff like that on our infrastructure. Then we will see a concrete case when we process rolling upgrades. So Linkfluence provides social media intelligence software in order to list trendy topics. So we can track influencer with our software. We can measure e-reputation. How we do that? We crawl the web and we gather data on social networks, on Twitter, Facebook, you know, all these social networks, but also on Russian social network, VKontakte, which is more known for its nudity, and another Chinese social network, Sina Weibo, which is more known for bots, spam retweets, or things like that. We also enrich the data. Like we say if a comment is positive, negative, if it's coming from a male, a female. So we do that by applying NLP analysis on the machine learning algorithm. So we have a lot of customers. They use our software in order to do queries, to have marketing studies and stuff like that. And we also have people that internally that work for them and do the queries. So we index 50 million docs every day. It's available in an archive of 70 billion of documents. In terms of infrastructures, it's 200 Elasticsearch nodes spread on different clusters. So our data processing stack consists on Hadoop. We have Storm, Spark, and we use HBase for our column store. So in terms of development, we develop Clojure microservices, and we have a Scala backend, and we have some Scala microservices also. So our infrastructure is hybrid. It is a particularity. We mix BareMetal on VMs. We also mix providers. Like we have Leaseweb. So on Leaseweb, we have very robust BareMetal servers, but we also have OVH. So on OVH, we have a cheap BareMetal server, but also cheap instances for GPU, for example. We also use AWS. So 95% of our VMs are deployed on AWS. And we also have a few instances on Chinese cloud, Aliyun, which is known more as Alibaba Cloud in France. So our playbook are cloud provider agnostic, also provider agnostic. It means that we can provision and deploy apps on Leaseweb, OVH, AWS with the same playbook. So that's a particularity. And we try to turn more to infrastructure as code. It's a pattern we try to apply as much as possible. So that's why we use Terraform. So before using Terraform, we were creating every resources manually. Every launch configuration, for example, on AWS, you have to go in the interface to click and select to create the launch configuration. You have to select your AMI, instance type, storage, etc. That's a lot of stuff you have to do manually. Same goes for the scaling group, where you have to set the group size, network, subnets, etc. So that's a lot of resources you have to create manually. If you want to go to another cloud provider, you have to use another UI interface, more and more resources to create manually. So that's you have a lot of resources to create. That's a bit boring. That's redundant, etc. So that's why we use Terraform. It's a simple template file. Sorry, it's not verbose. It avoids us to do redundant operations, and it's fully infrastructure as code, which means the template can be hosted in a Git repository. We can do version control then, and we can do what you can do with code usually, like pull request, code review on your infrastructure. So that's cool. And last but not least, you can keep track of your resource states, which means that you keep a state of your infrastructure, and you can go back, roll back to this state. So it's a simple file. That's the template, where you can see we created there auto-scaling group resource. We specify name, max size, min size, the capacity of the scaling group. We force delete, etc. So that's very easy to use. Then once you have written your template, you can generate your plan. So it's a dry run, which means it doesn't do any operation on your provider, on your infrastructure at this time. It just tells you it's going to add resources, delete some resources. Then once you agree, you can apply. So you do a Terraform apply, and then it generates the state of the infra. So it's a file, it's a TF state. You must keep this TF state consistent, which means when you are working on your templates and you are applying your changes, your coworker must have the latest version, and they should not modify the TF state also. So you should keep this TF state on S3, sorry. It's a backend on AWS. And you should lock it in order to keep it consistent. If you have bulky templates, you should use a module. Then we tried 2 patterns actually. So we tried to use the same TF state in a region. And it was a bit messy because when someone modifies a resource, it can by error modify like network resources or VPC connection resources, which can become a bit touchy, while you just wanted to modify the app you wanted to modify. And in order to keep consistent the TF state, it's better to use one TF state per app. you have less chance that someone is modifying the TF state on which you are working on. So that's better to go this way. You just use one TF state per app. Okay. So once the machine is up and running, once the instance is spawned, to provision it, we use a homemade cloud init. So it's just a script that will set the DNS on our cloud provider, like with route 53. On Leaseweb, on the OVH, it will set the DNS manually. Then we set the monitoring agents with Kochi Riemann. That's closure agents written. So. Then we download our Ansible playbooks and we execute the playbook to set the app, to provision the app and install the app on all the specific packages to the app. So then we have an inventory that we developed internally. So it's just an abstraction of cloud instance on BareMetal servers. It's to list what we have provisioned, what we have installed, etc. So we have this web UI where you can see all the hosts, instance, and containers that you have installed. Sorry. We also have an API and a command line interface to interact with. And then in Ansible, we have used dynamic inventory, so we can use this inventory with our playbook easily. Yeah, that's cool. So the fact that we have multiple providers helped us to be safe against provider outages. Like this summer, we had big issues with OVH. OVH was completely down, but our Elasticsearch cluster is spread on OVH, but also on Leaseweb, so it was still up and running. And we had a little downtime, but it was quite acceptable. But we were still up and running while all the website that was only hosted on OVH was completely down for long hours. We are also not limited by our provider. Like for example, we had GPU instances on AWS because it was firstly available there. But OVH managed to get a cheap price on GPU. We had the cheapest price on GPU on OVH. So that's why we migrated all the GPU instances from AWS to OVH. And we used the same playbook to do that. So we are totally not limited to our provider, and we can move provider to provider if the price becomes lower. So we can also do hybrid cool stuff. Like for example, if I want to test, I don't know, Kubernetes on some provider because they set Google Kubernetes or whatever, or Fargate, we are not limited. Also, when we want performance, we want high frequency CPU, we go to BareMetal, we use BareMetal. And then if we need to scale out and to overflow in the cloud, we can still use the same playbook to do that on Terraform to do that. So last but not least, my topic is about rolling upgrade. We can also perform rolling upgrades on BareMetal clusters. So in my case, it was on Storm. So Storm is a real-time data processing software. It's actually a topology. It's a directed acyclic graph where you have spoots. Spoots are the entry points of the topology. So and you have bolts that are used for the processing. That's the vertices of the graph that you can see there. So spoots is a tap. Then you see the vertices with bolts. And streams are the edge on the graph. That's the communication intervals. So one thing we can note about Storm is that the guarantee processing we are using is at least once. So that's guarantee processing that you can see in other softwares that do the same thing, like Apache Flink, etc. So, but you can also use at most once or no guarantee processing. So we have multiple topology deployed in our infrastructure. We have topology that we call Stein that are used for web and social networks. They are really lightweight topology, so we deploy them on AWS directly. But we also have a topology deployed on BareMetal because this topology is CPU sensitive. It requires high frequency CPU, and we use it for natural language processing, and internally we call it PNL, for processing natural language. But it's also spawnable on cloud since we are provider agnostic and our playbook are generic. We can use the same playbook to deploy PNL on the cloud. So one drawback we have on Storm is when we want to perform a rolling upgrade, we are losing the real time, so which means we have a delay in our pipeline. So that's why we had to find another way to do our rolling upgrade, and we do not use the feature that is available since the version 0.10 or 0.10. Sorry. So we were stuck with that. So that's why now we deployed a totally brand new cluster just to perform the rolling upgrade. So how we do that? We just Terraform plan and apply this cluster. It's a new cluster. So, and we have our Ansible playbooks provider agnostic that does that installed Storms as new cluster. So to list briefly what we do, we spawn the new cluster with the newest version of Storm. Then the new cluster process the data that is coming in our spot. We shut down the BareMetal cluster. So we have only the cloud cluster that is running and processing all the data. Then when it's validated, we perform the upgrade on the BareMetal servers. Once the upgrade is done, and the pipeline can process data, this BareMetal can also process data. We shut down the cloud cluster, and the operation is complete and successful. So as wishes on the work in progress, we are actively working on Dockerstein. So it's a development environment for Storm topology. It's based on Docker. So when we develop new topology and we develop new bolts and stuff like that on Storm, we use this environment. We use Dockerstein. It's not planned to deploy it in production. So because we do not have an orchestration system for Docker containers currently, we are working actively on Kubernetes. But as a higher priority, we will work on our microservices first. We'll deploy on Kubernetes our microservices on our GPU containers, because our GPU containers are using NVIDIA Docker for an image recognition project. And that's the first step if we go to Kubernetes. So we have a lot of things in our roadmap. We still need some people. We need you. So we are recruiting. We have open position for DevOps and Clojure and the Scala developer. So you're welcome if you want to join us. You can contact us after the session, etc. So thank you for your attention. If you have any questions, just let us know in English or in French, because my English is, I have a little French accent, if you may have noticed. Thank you.
Justement pour les questions. Pour les questions, si vous avez des questions, on va prendre 5-10 minutes pour les questions et on enchaînera avec le prochain. Je ne sais pas si vous avez des questions. Peut-être moi j'ai une question par rapport au Terraform.
Ouais.
Vous gardez les states dans S3 ou dans un Git?
Non, en fait, on les garde sur Git parce que vu qu'on a découpé en plusieurs applications, du coup, on est suffisamment consistant dessus. Ça arrive très peu souvent qu'on modifie tous la même stack, quoi. Du coup, c'était ça aussi, de faire le pattern et d'avoir un TF state par app, bah, ça nous a facilité la vie là-dessus. Alors qu'avant, on avait le même TF state et du coup, on modifiait tous les ressources en même temps. C'était un peu plus le bordel. Et si quelqu'un touchait au network, bah, ça devenait vite un cauchemar, quoi. Voilà.
Yeah, sorry, I was speaking in French. So the question was regarding the S3. They used regarding the TF states. They use S3 as a bucket, and I asked if they use Git for the versioning or use S3. So the question was Git actually, and you can re-explain it in English.
Yes. So actually, we use Git to store our TF state because there is we do not modify at the same time all the same app, and since we use one TF state per app, it's quite acceptable. While before we used one TF state per region, and this was a nightmare when we were modifying the TF state. So, but it's in Git.
That's great.
Hello, two questions regarding the inventory. First, did you try something called currents? That's what Tumblr, I guess, used to manage an inventory. And secondly, how do you handle the BareMetal inventory? Does your custom inventory solution discover everything for every provider you use? How do you handle your own instances? Do you have something that, you know, push who I am to your inventory or whatever?
Okay, so in our homemade cloud init stuff, we call the API of the providers and stuff like that, so the machine can register themselves. For cloud, it's pretty easy, but for BareMetal, it's different. We use the API of OVH on the Leaseweb directly, and that's how we can register the BareMetal machines on our inventory. So.
Thanks.
Yes, I don't know Storm that well, but your rolling upgrade is to upgrade the actual Storm framework platform, or is it to put new versions of spouts and bolts? And how long does it take?
It's a hack actually, because since we spawn a new cluster, we perform the running upgrade on without the fixture. We just upgrade the software directly on the machines, and then once we have the new version of Storm installed, we can deploy the new topology on the new bolt. So we'll restart the topology to do that.
Okay, and how long does this take? I mean, how big?
It depends on the topology, but it can take 1 minute just to restart the topology directly. So it's quite acceptable. And we process the running upgrade only when we have to upgrade the software directly. But when we upgrade the topology, we do not spawn a new cluster, etc. So 1 minute is okay. And it's 1 minute for the heaviest, the PNL topology. Rest is like in 10 seconds, 20 seconds, it's fine.
Okay.
So, is there any last question before we move to the next slide? Yes.
Hi. You said that you are using Cloud Init to set up instance?
No, it's a homemade Cloud Init actually. It's scripts that we launch at when the instance bootstrap, but it's not a Cloud Init.
From Canonical?
Yeah, no.
Okay.
So thank you very much, Pierre.
Thank you.
So if you have any more questions, so we can ask them afterwards around beers and pizza. And now we'll welcome our second speaker, Anthony.
Hello everyone. So thank you for coming. So today I'm sorry for Leaseweb being there, especially because they bought WebForce. But I'm not going to talk about really deep down infrastructure and BareMetal, but rather why we choose to move to Kubernetes for some projects at Algolia. So I'm Anthony, working as a software engineer at Algolia for the last 2 years. Oh, sorry. It's impressive. And so Anthony, working as a software engineer for the last 2 years at Algolia, and I've worked mainly on backend systems that we run there. And that's it. Regarding Algolia, so I think a lot of people already know what Algolia is, but just to quickly present the company, we are offering a no-state search API that is replicated across the world. And on top of that, we are offering a lot of integrations and API clients to build your own systems or website or whatever. And on top of that, we are giving you a lot of tools such as the new analytics pipeline and stuff like that to help you understand how your search behaves and how your customers are behaving when they are using your search feature. So today I'm going to talk about Kubernetes. For those of you who don't exactly know what it is, I will explain it first, especially because there are a lot of different explanations about this on internet, and both are not as good as the one we can find on the official Kubernetes website, but it's a lot of documentation to read. Then I will present you the Algolia infrastructure and a few services that we run at Algolia, just so that you will see that we do also have an hybrid backend here. And we'll do a quick list of the pros and cons of Kubernetes. So the pros, you can simply find them on internet, whereas for the cons, it's a bit more difficult, especially because the technology is quite recent. So first, what is Kubernetes? It's an open source project brought by Google in 2014. And it's here to help you orchestrate your Docker containers automatically. Meaning that if you want to run a service or multiple services running on Docker, you don't really care about the underlying infrastructure. All you care about is how do I deploy my components? Do they scale with my infrastructure? And Kubernetes is exactly there for that. Even though the technology is quite recent, you have to know that it was created out of Google's Borg, which is the system that Google is using, or maybe not anymore. I can tell, I'm not working at Google, but they were at least using it for the last 15 years to orchestrate all their workload running on Docker on containers. It runs on like really any infrastructure. Being written in Go, you can find it easily on a lot of different platforms and a lot of different architectures. But as of today, the most used one are definitely BareMetal servers and infrastructure cloud providers, such as GCP, AWS, and Azure is a bit behind here, but is still pushing a lot for this. And of course, because on the internet you can find anything, you even have people running that on the Raspberry Pi clusters, which is absolutely useless, but why not? Huh? As for the components of Kubernetes, so you just need your physical or virtual machines to run Kubernetes on. And then you just install Kubernetes, the different kind of components, of course, that you have in Kubernetes. And that's it. Once you have a cluster that is provision with Kubernetes, this is exactly where you can start to build your software and run your software, and that's it. For that, you have two main tools, which are kubectl, the CLI that lets you control the Kubernetes cluster, and the YAML files that contain all the configuration of your different services, which is a bit like infrastructure as code, as it was described by Pierre just before. Finally, for local deployment, you also have a CLI called Minikube that lets you deploy a local version of Kubernetes. Not that useful in our case, but why not? It looks like this. So you're just writing your software as usual. The only thing is that to deploy it, you just create a Docker image out of it. And on top of your software, you need to write the different resource files, which are the YAML files I talked about. Out of this, you just use the resource files and the Docker images you pushed. And thanks to the kubectl command, you just tell your Kubernetes cluster, okay, I want to deploy this workload, this kind of services, do it for me. And it stops there. You don't have to care on which server your containers will run. You don't have to care about whether they will stop or not. We'll see that later. And if you have load balancers, Kubernetes can manage to use them for you and distribute the workload. It used to have contenders, so I think one of my friends here is an aficionado from Mesos, and but yes, as you may know, some Mesos frameworks were direct contenders to Kubernetes, but it's not the case anymore. For quite a few reasons, Kubernetes has won the war here, mainly because they are really fast at integrating new features, maybe too fast for some people. And Docker Swarm, I don't know, maybe Docker is out of luck with all the new products they are releasing because they are all dying one by one, so except for Docker. Describe what your services are. This is the main important point here. You have different kind of objects that you can deploy on a Kubernetes cluster. Your service as a Docker image is one of them, but not the only one. For instance, you can deploy load balancers. You can deploy services that will basically cover all the Docker containers that run behind a load balancer. So this is the first thing you have to know. What do you want to deploy? Then you send the configuration. So everything that is related to the service. And finally, if it's an actual software that you want to run on the cluster, you need to provide the Docker image. And that's it. From there, you can also define the minimum and limit resources that you want to use on the cluster, because don't forget that we are running on the physical or virtual machines, but machines do have limits. So you have to specify what you need and what are your limits. This is really important. And from there, again, Kubernetes does the rest. Okay, so regarding the Algolia infrastructure, it's quite simple. We do have the search API that is running on BareMetal machines. We are running on a lot of providers. Leaseweb is one of them. And the two main components that are running there are the Nginx module within Nginx that is serving all the search queries and build queries that we receive on our machines. And you have a builder that is on the side that is just building the indices that we use to search for your records when you are sending data. I've asked one of my colleagues this morning, Antoine, which gave me nicely all the up-to-date numbers. It's really hard to have them on the slide, so those ones are fresh. As of today, we have around 1,200 servers across 70 data centers, and we are available in 16 regions. Regarding user-facing services, it's not an exhaustive list, but we do have the website that serves directly algolia.com and all the subpages. The dashboard, so once you connect to Algolia, there is a Ruby on Rails application beyond that. Those are just running on VMs at AWS, if I recall correctly. We also have a WordPress blog, a documentation that is served via static files through S3 buckets. And we also have a status page and a lot of other things. But as you see, here we are already moving to a different kind of infrastructure. And finally, for the very recent backend services that we have, we are using Kubernetes mainly, that runs on VMs at cloud providers. And today I will mainly focus on the ones that are presented on this slide, because those are the ones we maintain in our team. So out of this, you see that we are already using different kind of providers, different kind of offers. What is the main reason for that? I think it's mainly that BareMetal is a necessity for our engine. That's it. It's just that we needed performance when we started the company. We still do. And we don't really see the point of managing other infrastructure than the one we are using for our core product. And I think it's a good advice to follow when we are a SaaS company. Of course, it's not the case for our backend services. We just want to develop. So I'll show you quickly one of the few pipelines that we are using at Algolia. So this is the one we are maintaining in the team I joined. As you see in gray, you have the Algolia API server. So remember, we have thousands of them, sending all to a log collection pipeline that is collecting all the logs coming from the engine. We are speaking about roughly 2 billion logs per day, and it's growing. Out of this, we store them in a long storage service. So we are mainly tied to GCP here. And we use a message broker called PubSub, which is just like Kafka, things like that, to collect the information about which logs were written. And those are the entry point for multiple different pipelines. And as you see here, the point that I want to make here is that we are only talking about the services and the components that we use here. But I don't really care about the infrastructure, because all of those, the one with the blue icon, they are running on Kubernetes. And from there, I don't really care about, okay, on the log collection pipeline, maybe server number 2 has still issue with the disk, or maybe server number 3 on the analytics pipeline will need to get upgraded to whatever version. I don't really care. The way I show you this schema is really the way we are thinking about the infrastructure nowadays. We don't really think about the servers anymore. And this is really convenient as a developer and also as for the DevOps. So let's go with a few Kubernetes pro points, I would say. Deployment. If you're a software developer, for sure, this one is important. Here, the only thing that you have to handle once you have a Kubernetes cluster running is you develop, you push the Docker image, and that's it. Then everything that happens after, it's your fault in the code, but you don't have to think about, okay, what's really my OS? Should I upgrade it? Should I apply security patches? And this is especially true if you are doing all the updates as it's recommended, and you don't really have the choice because Kubernetes is not well known for backward compatibility. And that's it. Updating and sending your YAML configuration is just to say, okay, my configuration has changed. Maybe I need to update this file, but this is just it. You modify your files, you send it to Kubernetes, and that's all. Your service is deployed. You do have rolling update also, so you have no interruption of services. Regarding the configuration, so if you know the 12-factor app methodology, which gives you in 12 points all you should do if you're writing services, externally reachable services. You do know this point, which is say that you should pass the configuration via the environment. Kubernetes is really following those rules, and it really helps you to do that in the sense that you do have key values that you can pass through the environment to all your running containers at the same time, which is really convenient. And regarding sensible data, you do have a kind of object that is called a secret, for instance, that lets you just pass secrets that are not externally available and only visible from the running containers. Autoscaling. So here we are really talking about infrastructure again. It's really convenient with Kubernetes because you can just describe what's the CPU and the memory you are needing for your services. And Kubernetes will manage to find a spot, find a space where it can run it, and that's it. Of course, you are limited by the physical servers that you have behind, but besides that, Kubernetes does it for you. If a machine cannot start a Docker container somewhere, you will try it somewhere else, and you don't have to think about it. Also, they are moving quite fast, and they deployed recently the custom metrics-based autoscaling. This one is really important because it's really difficult to know how much of CPU and memory you will need to run correctly your pipeline or your website or whatever. And since very recently, you can autoscale based on the custom metrics that you want to choose, which is really convenient. And the autoscaling is really, really awesome when you are working with infrastructure providers such as GCP and AWS, because those ones, as you know, you have instance group, autoscaling groups. I don't know what they are named in depending on the cloud provider, but it lets you just tells, okay, autoscale the number of containers, and if the number of containers cannot run on your cluster, it will also autoscale the physical machine, enfin, the virtual machines that you have under the hood. So again, everything is really completely transparent to you. You have nothing to do. Lifecycle management. You all know the sentence, when in doubt, reboot. This is especially true for for Kubernetes, because every time a Docker container is stopped or stopped working for some reason, you will try to restart it somewhere. It sounds really dumb when you say it like that, but actually, how many of you have already restarted just a service or a server just because of an issue, something that leaks in your code or whatever? Doing that for you, it's really convenient because you can keep track of how many times a service was restarted. So it will be easier to find issues. And also all the auto-scaling and rolling updates stuff is completely based on that and on the lifecycle management that is existing out of the box with Kubernetes. And finally, to me, the really important point with Kubernetes is that the project is really moving fast. You have a huge community, and it's really, really well integrated with cloud providers. And I think this is the main reason it's so popular these days, is that, okay, you want to go with GCP, you just click, and you have a cluster automatically deployed for you. You don't have to even think about deploying it yourself. And a lot of promising features are coming in those days, especially regarding authentication and long-term storage, because they have no issue with the storage in the past, and they are fixing stuff. They are not really letting people behind. Okay, so all the things you can pretty much hear the same everywhere on the internet. So what are the bad things that we discover with Kubernetes after nearly 2 years? It's not true. You actually have to care about the infrastructure. Why so? How do you know what resources you will need for your service in advance? What is the worst case scenario that you will have to handle? Okay, once you have this answer, you know which machine you will need to run under your cluster. And until that point, you cannot know. And all the scaling issues that we had regarding the physical resources that we needed, we discovered them in production, exactly not on working days and at the worst time. So it's true that it's abstracting the infrastructure for you, but as a developer and as an operational guy, you will still have to think about the infrastructure. It's completely untrue to say that Kubernetes does everything for you. In terms of monitoring, we have seen that previously we are really mainly monitoring the machines themselves. It's still important to do that, but with Kubernetes, knowing that you will run mainly containers that are ephemerals, that will run on different machines, you cannot know in advance where your container will end, where your services will run. It's really not different, but not really maybe relevant to monitor the machines themselves. So you still need the monitoring. For instance, if you are GCP and you are providing a Kubernetes cluster on demand. But for us, it's not really that mattered. It's really about monitoring the services themselves. What's the throughput of your services? What's the error rate? Have something changed in the past? What's the current latency of my services? And this is where you are really you really have to think about this more than about the infrastructure. Learning curve. I don't know how many people have already played with Kubernetes or even using Kubernetes in production. Okay, so you probably know that the documentation is not that great. It's getting better and better, but still, even this afternoon, when reviewing my slides, one of my colleagues pointed me to the documentation, and clicking on one link, I ended up on a document that was outdated for the last 8 minor version of Kubernetes. So it's really, really bad. And because of that, you should really think about onboarding people from day one if you plan to use Kubernetes. Why so? Because it's really easy to find people that will help you on the infrastructure. Anyone can SSH to a machine and find useful information if there is an issue. Troubleshooting a Kubernetes cluster, it's a different thing. Either the issue is on the infra, either the issue is in your code, either the issue is on the Docker container that doesn't have enough resources. And everything that you learn by using Kubernetes, it's not properly documented, it's not really state-of-the-art yet. So think about knowledge sharing from day one when you are using Kubernetes. yet another system to manage. It's not true, obviously, if you are using a cloud provider such as GCP, because they do it for you. But it's still something that you have to think about. And again, if you go with on-premise solution, think early about centralized logging. We are completely under GCP here, so we are using the logging platform of GCP. But if we were to do it ourselves, the first thing we would do is to have a centralized logging system to make sure we have all the logs and we can debug everything from there. Otherwise, it would be a mess because you have to connect to all the machines, all the Docker containers, know which Docker container is running on which machine, know how your load balancer is behaving. It's really a mess if you don't have a central place to collect everything. So in short, if you're planning to use the Kubernetes after my talk, think about those questions. Do you struggle maintaining your current infra? If the answer is no, okay, maybe it's not the right thing to move there. If you already have something that works, that is not an issue for you or your team, and that is not a technical debt, okay, maybe you can just keep what you have for now. Is your load expected to grow? At Algolia, it's really, really important to know that, because on average, we are doing factor 2 in terms of volume of logs that we are treating every year, which makes it around factor 10 for every 3 years. And we needed a product that will grow with us. And for that, we are really happy so far, because the load is just growing, and it's expected, and everything works with that. But if you just know that you won't take that much of load in the next years, maybe don't use that. It's really a big learning curve and a lot of things to change for maybe nothing. And finally, can you afford Kubernetes on infrastructure as a service provider? I couldn't see myself deploying Kubernetes alone with all the things that you need around, the monitoring, the logging, and everything. So I highly recommend you to use GCP, AWS, Azure, whatever, IBM. IBM is a good provider also for that. No, don't know why. But yes, it's really convenient, and you will save a lot of time by using tools that are already there for you. But again, it's always a problem of money. So really up to you, but consider that in advance. Thank you for your attention. I just forgot to mention, as Pierre, that we are hiring a lot at Algolia. So if you are interested in those things, or even in mainly in the backend roles and the infrastructure roles, we just have the offers at near the entrance. So, and feel free to reach to any Algolia employee. They are super happy to find new people to help us on the workload. So, thank you.
Thank you very much, Anthony. I think we are going to get a lot of questions regarding Kubernetes. So I'll start by the back and move forward.
Yeah, I had a question regarding Kubernetes running on BareMetal. One of the major pain that we encountered with our clients is that one of the big advantages of Kubernetes running on cloud is the cloud controller manager, the fact that exposing as services uses the given load balancer and every other stuff. I was wondering how difficult was it for you, and how much time and effort did it take to re-implement basically your own version of the CCM for the BareMetal?
What's the CCM?
The Cloud Controller Manager. Basically, if you want to expose a service of type load balancer, you have to expose your own logic if you're not BareMetal for storage and stuff like that.
Okay, so I cannot tell for BareMetal hosted Kubernetes cluster, because we, as I told you, we used the GCP one. If it was to re-implement, if that's the question, I cannot tell. But I really fear that it will take a lot of time. This is what I try to explain in my slides, because considering all the things that are done for us and that we can take for granted when using GCP, every time we do have a service that, oh, GCP does it for you, I was like, okay, I don't want to deploy Kubernetes myself. So but maybe I'm too pessimistic.
Thank you.
I got another question about Kubernetes on BareMetal.
Sorry.
How you mentioned that your search API runs on BareMetal, yet do you have any stateful applications? I mean, I want to know what you use for persistent volumes, how you deal with the pain of not having network attached storage as easy, or I mean.
So your question
Ceph
concerned the
or anything? Yeah, I want to know if you have anything stateful on BareMetal, which was most interesting for me.
For the engine, the only thing that we run is the engine and the builder and everything related to the search API. And for that, the only persistent storage is the actual disk of the machine that is then synced on a regular basis to our long-term storage solutions. And this is it. But the thing is that with Algolia, every time you start, you create a new application, your application is actually replicated across at least 3 machines. So we don't really care about losing a machine in the end, because of the way Algolia is designed because of the way Algolia is designed. So if we lost a machine, we still have 2 to perform the indexing and the search. And if we lose 2 machines out of 3, we are still serving the search from 1 machine, and we have the time to replace them and reproduce the missing ones. So we don't use long-term storage or Cassandra or Ceph or whatever.
You don't use stateful sets, actually, since you can't really map hosts.
Not for BareMetal.
File systems. Okay, not for BareMetal. Okay. So
not that I know of, but if there are people from the Search API squad.
Hey, first of all, congrats for your presentation.
Thank you.
So I would like to know, actually, how do you deploy to Kubernetes? Because even though it's kind of, okay, it's just a matter of YAML files, it's kind of painful to modify the YAML files. So actually, what we do is to use something like Helm, or I would like to know if you use it, and how do we integrate it with your tools like Jenkins or GitLab CI or something like this?
Okay, I 100% agree on that. It's painful to deploy that when you don't know how to do it, and it's especially painful because it's YAML.
Yeah.
So yes, it's a question we're asking ourselves more and more these days, especially because we will move to multi-region infrastructure for that, because customers want to have their data collocated in some regions and stay there, mainly because of GDPR, for instance.
Yeah.
For that, the solutions we are looking at are obviously Terraform, because it's more agnostic, and because we are running on GCP again, we can use the gcloud deployment manager thing that they provided, which is just Terraform but for GCP. And yes, out of this is the best way we are thinking about maintaining all of that. Just having everything in a Git repo and versioning with Git all the files, and infrastructure as code as everyone else.
Okay, and just one more question regarding the monitoring tools. You said that you monitor the services. So I would like to know which platform do you use to monitor, like if it's Datadog, Sysdig, or Grafana with Prometheus?
We talk with them. At the beginning, all those pipelines, we wanted to build them upon SaaS providers, but it was too huge in terms of volumetry for them and too costly for us. So what we've chosen is to build our own stuff on Kubernetes on GCP. And for the monitoring, we were using, and we are still using, a tool called Wavefront, if you know it, which have been acquired by VMware recently. It's just a time series database with a super query language on top of it. So we do push those our metrics to that services. And also with GCP, again, sorry for providing so much good feedback for them, but they are providing something called Stackdriver, a company that they acquired too, which is really well integrated with all the GCP services. And thanks to those 2 things, basically, we have been able to monitor everything. So yeah, it's the main thing. So we are not deploying something on our side. We are just using either the SaaS company, the Wavefront thing, or the offered one by GCP.
Okay, thanks.
Hi. You mentioned the recent edition of autoscaling based on custom metrics. Are you using it, and if so, on what custom metrics from your services are you?
No, we are not using. Sorry, I finished. Sorry. So no, we are not using it. Yes, we considered using it, mainly because for one of the pipeline, as we are using PubSub to know what has to be processed, we wanted to have an idea of when to autoscale. And when do you want to autoscale? When you have a message queue, it's when you have too many messages in the queue. But the thing is that the only thing that were available at the time were the CPU-based autoscaler and the memory-based autoscaler. But in both cases, it's super difficult to think about, okay, I have that many messages in the queue. Where do I put the threshold in terms of resources to know when I need to autoscale or downscale? And so for that, we would have used custom metrics to just fetch the number of messages from the queue, push them, and base the autoscaling on the number of messages. The only thing is that we haven't done that recently because in the end we found a better solution, but it's really specific to the project. It's not a magic solution, it's just that we don't need the autoscaling that much and CPU is enough for now.
Thanks.
Hi. You didn't talk about the central services like etcd, and I would know how, what is your topology, how many masters do you deploy?
How many, sorry?
How many masters, nodes do you deploy? And also if you have many clusters or just playing with one?
No, for the second question, no, we have multiple clusters, one per service, as I showed you on the slides before, but
okay,
it's mainly for making sure that one cluster is dying in terms of resources, because it happened in the past. We are not impacting the other services. It's as simple as that. Regarding how many master nodes do we have, what's the topology? Again, I don't know. It's managed by GCP, and I'm really happy to not know about that, because in the end, I want to be a user of Kubernetes, even though I want to have access to all the features, understand how it works, but I want to be a user first, and I don't really care about the infra.
Okay,
I would have to if I was using BareMetal.
Okay, thanks.
I have a security questions concerning your containers. How do you manage credential or certificates when you have a service that used to communicate with another?
Okay, so the first service that we had on my slide with the schema, this one is exposed over the internet, so it's an endpoint. For this, regarding security, we are just using certificates plus oath, basic oath. Sorry.
Are they embedded inside the images?
The certificates. Let me think.
I mean, how do you manage through your different environments? I guess you have.
Okay, so we are passing everything through Kubernetes secrets, first thing, and regarding where do we store the secrets before Kubernetes, it's in HashiCorp Vault. We do have an HashiCorp Vault cluster at Algolia, and so the only time I need to access and use the secrets is when I do an actual deploy of the configuration. I just fetch the credentials from Vault and push them in a Kubernetes secret, and that's all. And they are not leaking anywhere normally.
Perfect, thanks.
I would like to know, for the developers, how do they manage the containers which are killed anytime and things like this? I mean, do you have a special instruction for them?
The thing is that if it was your question, the thing is that you have to think stateless from day one. If you think about big monolith with strong dependency on the disk, on the physical storage, it may be an issue, because in our case we don't use the disk at all. Everything is in memory, so we just take what we need from storage, PubSub, process what we need, and write to the table. And some of our pipelines are even idempotent, so we don't really care about whether or not the container is killed.
And about SIGTERM, SIGINT, or things like this, you do nothing.
But we do catch them to correctly clean our app, because for instance, we are using context, so we just know when we receive those kind of things, because this is the way also Kubernetes is telling you to stop something. So we just catch them, try to clean what we are doing properly, and eventually we will restart. We have multiple replicas of our different services components, so we don't really care about losing them. It's everything is stateless. So
I got another question. Have you tested OpenShift or another solution like OpenShift?
No.
No. Okay.
Thank you. If you do just pub/sub compute, why don't you use something simpler like lambda computation or directly?
We haven't. Two reasons. We haven't tried, so cannot tell. Maybe
Mhm.
it's better. Huh? Second thing is that at the time we started, cloud functions were not available. We started the project 2 years ago. And last thing, the process are actually quite quite important in terms of CPU usage. And I haven't tried them, but I know that AWS Lambda and Google Cloud Functions are not that well behaving in terms of quotas. So you really have to stay in the quotas, otherwise it's either expensive or not permitted. But yeah, maybe it's a solution. Maybe at some point we'll move to that, because yeah, it's the current design to have everything in your message queue, pass to functions and everything. But it was not available 2 years ago.
Thank you. I have a question. You said you have multiple Kubernetes cluster. Do you use federation? And another question, how do you handle security in your team? Do you use airbag authorization or something like that?
So no, we don't use a federation. Maybe we should. I don't know. Regarding security, what's airbag?
Airbag is a role-based authentication control for all your team. Do you have
Never
all
heard of that.
admin,
Never heard that personally, but maybe someone in my team is more knowledgeable than me on that, but we haven't used it yet. But happy to discuss it afterwards, because
Okay.
improving the security, it's also a priority. So.
Okay, thanks. It's a recent since 1.8. It's since 1.8 version.
Yeah, but they were not stable that much.
I
don't know which version.
1.10 because we are 1.9 because it's the stable one. We could have upgraded to 1.10 because being a happy GCP customer, you do have access earlier to oncoming release, and plus they are doing all the security patches more quickly than the upstream. So we are really used to migrate often. So 1.9, 1.9, sorry.
Do you use any image scanning for your images?
To detect vulnerabilities, you mean?
Yes.
Google does that for us.
Huh?
Google does that for us.
All right.
We just have the green logo or the red one, and that's it. And we do use Alpine most of the time, so not too many issues with that.
So thank you very much, Anthony.
Thank you.
So Nico is going to be our last speaker. So welcome, Nico.
Hello, everyone. Good evening. I'm indeed the last speaker. I think in 30 minutes we have pizza. And actually, my this third talk of today, my talk, is actually about the cost which is involved in running a continuous integration infrastructure in-house. As you heard from Algolia and Linkfluence. And Leaseweb is no different. We are all looking for smart people to join us, work for us, and work on what our core business is, which is either search, hosting, or analyzing trends. You don't want to waste a lot of time in maintaining a CI infrastructure, and that's what this talk is about. So I quickly introduce myself. My name is Nico Di Rocco. I'm located in Amsterdam. I am a DevOps engineer for Leaseweb. We are an infrastructure as a service provider. We host a lot of customers, Linkfluence, Algolia, we host them too. I work for Leaseweb for 7 years now, and recently I became a father again. Thank you. So what I want to spend the next 10, 15 minutes talking about is actually the story of how we at Leaseweb set up a Jenkins cluster and how that evolved over time. So what I hope is that you guys and girls can relate to some of the things that I say. And I hope that at the end of the day, you know, we can both walk away and we learn something new about continuous integration. So about 5, 6 years ago, we also got to the point, you know, where we realized we really need a continuous integration infrastructure. Who is running? Who ever worked with Jenkins? Okay, cool. That's nice. So some companies do this right from the start. Other companies start a little bit later. But at some point, you want a system to tell you, you know, about stupid mistakes that you're making. You know, a bug, or you deploy a new feature and you have a regression in another feature. You want a system to tell you this. So we also got to that point. So what we did, very simply, you know, we want to get things done fast. We installed Jenkins. You know, it's super easy. We work a lot with PHP, so you know we installed some of the development dependencies on the same machine, and we have a Jenkins server. And then what we started doing was, you know, you log into Jenkins, a couple of people have access, and you start adding jobs. And by default, when you set up Jenkins, you get this empty container. So you pick the first one, freestyle project, and you start, you know, adding all of your Git repositories to Jenkins. And well, most of you worked with Jenkins, so you're probably very familiar with this, you know, big form that you need to fill in. You know, where is your repository found? How does it, you know, do you check it out? You can define all the build steps here in this user interface in these nice, beautiful text fields. So you're at this point, and then you think problem solved. For the record, this is not what I do with my kids, by the way. But then, you know, over time, you get more people who, you know, in your company, in your team that want to onboard on your Jenkins project. So you get a lot more Git repositories in there, and you start, you know, cloning maybe existing jobs. You start manually adding new jobs. Especially these days, you know, we value microservices a lot. I wonder if there is anyone in this room that works on one Git repository during a day or a week or month. We all work, you know, on several projects at the same time. So what you end up having is every Git repository that you have in Git is also a job in Jenkins that comes with its own settings. At some point, you find out this new setting which you want to apply to all of the jobs that you have in your Jenkins cluster, and you know, you start opening like 20, 30, 40 tabs, you know, clicking that same checkbox, trying to make that same change in all your jobs. So if you want to do it like this, you know, that probably works perfect. And if you want to scale, you know, you're going to give more people access to Jenkins who can do this. Then at some point, you realize that a job usually monitors a single branch in your version control system. You can configure it to, you know, build all the branches whenever there is a change. But when you do that last one, then sometimes you see, you know, your jobs turning red, you know, which usually is a sign that something is really wrong. And then it turns out that this is not a master branch that is being read. It's some kind of fancy topic branch of a guy who worked in the weekend and he wanted to try out something new. So all of a sudden you realize, you know, we need more jobs. You know, we need a job for the master branch and we need a job for all the other branches, for example. So now you don't have a linear growth anymore with amount of repositories and amount of jobs, but it starts growing exponentially. So again, you know, probably works. And if you want to scale that way, you're going to give more people access. Then, you know, very obvious, you know, you realize that you are not only using PHP 7, for example, in your company, but there are still teams on PHP 5.3, teams on PHP 7.1, some teams use PPAs and have PHP 5.4, whatever. So at some point, what you start doing, you know, on this single Jenkins machine, you cannot have all that software installed there unless you do, you know, magic. So you start introducing slaves. I think Jenkins calls this concept nodes. So you start creating nodes, and every node, you know, has labels trying to describe the software that they have installed on them. So, you know, at some point, you end up with a Jenkins master and I don't know how many slaves with all the possible combinations that there are. So these are very heterogeneous systems, which, you know, need maintenance. You need to keep these guys updated as well. If you want to maintain this, you know, that's fine. You're going to give a lot of people SSH access to this node so they can upgrade packages and whatnot. And then, and this is, I think, a very beautiful one, then at some point, you know, you get another team and that says, no, excuse my language, but fuck this shit. The existing Jenkins cluster, you know, is no good. We're going to build another one. And then you have the thing times 2. So this is not maintainable. And actually, what is the problem here is if you have this situation, which at some point is what we had, you know, if you start counting, you know, the numbers, you have a lot of effort and hours going into, you know, your CI infrastructure. You have very little consistency because everything is, you know, manually added. Some jobs, you know, use this configuration, other jobs use the other configuration, and actually you need you know, a lot of people who know Jenkins and who know all the concepts and know how that works in order to try, you know, to maintain consistency. And that doesn't work. So all of a sudden, you know, you try to solve a problem and you have introduced a new one. So one of the solutions, and that's actually the solution that we did, but there are others, you know, you can go to Travis CI or, you know, any other hosted continuous integration infrastructure product. But what we chose was to set up Jenkins a little bit differently and utilize containers. And we recognize that there are a couple of things which are key to simplify. And first of all, that is, how do you manage all those jobs in the user interface in a sane way? So it shouldn't grow exponentially. It should be easy. The other thing is, how are you managing how an application is built? You know, every application is a little bit different. You don't want people to, you know, fiddle with this text field in Jenkins where they, you know, write this bash or Python scripts, whatever, how their application is built. So somehow you want to, you know, version control that as well. And the third one is, you know, you don't want to have all these heterogeneous slaves. If you want to have slaves, you know, it's for scaling because you get a lot of repos in your Jenkins cluster, but you know, ideally they should all be the same. So we identified that these 3 components is what you probably need to simplify. So about simplification number 1, something what Jenkins has, and it doesn't come by default, but these are plugins, and I think they are recently adapted also by the Jenkins CI community, so they're maintained by Jenkins themselves, is something what you call organization plugins. And organization plugins, what they do is, and I'll show you that in the next slide. Well, in the next slide, I have 2 examples of a GitHub and Bitbucket server organization plugins. I think you have many more. But what you do here is, in our example, we are using a self-hosted Bitbucket server. What you do is you point it to your Bitbucket server, and then you specify the organization name, you know, you want all the jobs to be imported from. So in GitHub, you have something like github.com/leaseweb or github.com/Algolia. Algolia is the organization name. What this plugin does is you point it to the organization name, and after you configured it and you click save, it starts using the API of the version control system, so GitHub or Bitbucket server, and goes, you know, discover all the repositories that are behind this organization. Then it loops through all the branches which are inside these repositories, and it will automatically create jobs for them if they fit some criteria. So we at Leaseweb, we have about 10 teams. So that means that right now we are maintaining 10 things in Jenkins manually. And these run, you know, on a daily basis, and they automatically discover new Git repositories, new branches. I think we have about 200 Git repositories in our Jenkins and a multitude of that of different branches, but we are not adding them manually anymore. We just have 10 of these organizations in there. And the nice thing is that now you get jobs for every branch. You can even get jobs for every pull request. So now when master is red, you really know that you have a problem which you need to look at. And it's not that topic branch of someone who wanted to try out something new anymore. Then one vital thing of organization plugins, and that's how they work, that's how they discover jobs that need to be created, is what they are looking for inside your Git repository of your software, or your Ansible playbook, or your Chef cookbook, whatever you have version controlled. They are looking for a Jenkins file in the root of the repository. And when there is a Jenkins file, it will create a job in Jenkins. And this Jenkins file is, very much, in concept similar to the Travis CI file or the Circle CI file that you might know. There you define in a special kind of language all the steps that need to be taken for you to build or test your software. So this is a Jenkins file of one of our projects, and here you can actually see that we are defining a couple of stages, and in every stage we are running a shell command. And in our case we are using make to do the actual work, but you can just have your commands here, whatever is needed to build or test your project. So this thing gets then interpreted by Jenkins, and every time there is a new commit or code change on this branch that has this Jenkins file, Jenkins will run these steps. And in the user interface, that will then look something like this. You get a nice overview, you see all the stages, you see how long they take, you get the logs per stage. Then you might ask that at some point, when you have like a lot of Git repositories, 20, 30, 40, then those Jenkins files that you have in every repository, they, look the same, because every project needs to have a Git checkout. Maybe every project you want to notify your Slack channel or your HipChat room that the build is started or that it failed. So there is a lot of boilerplate code in that Jenkins file, and that becomes at some point also very difficult to maintain. I would definitely not suggest starting out with this, but there is actually a concept within Jenkins which is called global pipeline libraries. And what you basically can do with that is you can build these like code snippets that you can then reference in your Jenkins files. So if you see at some point you're making a lot of repetitions in Jenkins files, this is something that you'll probably want to look at to get rid of that duplication. Actually, what you are doing here, so you can actually see that we do it as Leaseweb. Here you see that we are calling a function. This is actually Groovy, by the way. I don't know who of you knows Groovy. It's a superset of Java, if I understand it correctly. So under the hood, this is actually Java. And what we are doing here, we are calling a function lswci with some arguments and a body. And there you actually see the implementation of that function, and what it does, it is simply Groovy, and it takes care of some boilerplate stuff, like a try catch, notify the build has started, and I redacted the rest, but you can imagine what other repetitive stuff would be in there. And this body that you see here is getting executed right there after the git checkout. So this is how Groovy works. But enough about the global pipeline libraries. Actually, now I want to get into the third simplification, which is the slaves. And this is kind of obvious, I think, for this group. Instead of maintaining machines with all the software installed on them, you have some amazing tool, Docker, which can help your development environment, production environment, but definitely your testing environment as well. So what you want to go to is you want to go to a point where you just have n slaves in Jenkins, and the only thing that they have is Java, because Jenkins happens to be Java, and Docker, nothing else. You should not care about these machines. If they die, you create a new one, it only has Java and Docker, and you attach it to your Jenkins cluster, and that's it. So no love going here. So then what Jenkins provides, obviously, is that in your Jenkins file, you can do all of these steps that we saw earlier. You can also do them in Docker containers. So we are doing the same. And what we started with is I'm not sure if you are familiar with that, with build containers. Basically, we created a few containers that contain all the software that we need to build a project. So we have a PHP container that has PHP unit and composer and PHP, obviously. We have a Ruby container and a Python container. These are highly opinionated, not meant to be shared with everyone else, but they contain the dev tools that you need to build a project. So we have some of those in all the languages, or for every use case that we have at Leaseweb. We push them to the Docker registry. Here you can actually see an example of what kind of software we put in there. So this is the PHP container, I believe, and you can see that we put there Git, build essentials because we are using make. You can put anything here that your project depends on. And then, once you have this, you can actually modify the Jenkins file, and instead of having their stages that execute shell commands, you can actually wrap them in a function to make sure that these commands actually run in containers. So what you are seeing here right now is a job that gets executed on one of the Docker slaves, but every shell command is executed in a Docker container, which just exists for the duration of the shell command, and when the shell command is finished, it dies. And here is even an example where we use the Jenkins file to build a Docker container and ship this to our internal registry. So then you get to this point where you have one machine, the Jenkins master, you know, that you want to take care of, and you have a homogeneous set of Jenkins slaves, be it 1, 2, 10, or 100, depending on how much power you need. So this is the point where we are now at Leaseweb. This is actually what we have. And what we are looking at right now is to see how Kubernetes can even make this easier. Because what we still have now is the concept of a Jenkins master and slaves. And we are still responsible for maintaining that relationship between the master and the slave. If you have a new slave, you need to manually add it back to Jenkins. You need to go through a UI. You need to click some things together. And actually, Kubernetes here can solve that problem, and it can completely get rid of the concept of slaves. And this is something new in the Jenkins community, but I believe and it's also being adapted by Jenkins itself. So I believe that in the future, this is going to be, by default enabled in Jenkins. And actually, what that does is, instead of relying on a slave that you manually created and sits there for its lifetime connected to Jenkins, what happens is that the moment you push some code to a topic branch of your Git repository, when that change is registered, the Jenkins master will actually use the Kubernetes API to build a slave just for that particular job. It will run all the commands of your Jenkins file, and when that is finished, it will kill the slave. So instead of having long-living slaves, you get just slaves per Git commit that you do, which simplifies it even further. That's it. You have any questions? Yes, I see one.
Hi, did you give a try to Jenkins X that was released like 1 week ago and natively support Kubernetes?
Yes,
What do you think about it?
I think the first hour I said "what the fuck" like 100 times. Again, excuse my language. I can't wrap my head around it. It seems, I think it's trying to solve a lot of things, and that makes the use case very small. But to be honest, I haven't played with it yet.
Thanks.
Have you ever, so you run your builds in Docker containers, right?
Yes.
You haven't encountered that problem where you have it runs inside the container as the Jenkins user, but the Jenkins user doesn't exist in your image.
Yes.
And so eventually it maps to root, and then it says, "Oh, I can't write anything."
Yes. This is actually that's what you see here. So this is a Docker file, of one of those build containers I was talking about, because we have Jenkins on the host as user ID 999. We are adding a user with the same name, Jenkins, but with the same user ID 999, especially to make things like SSH work. So we have a lot of private repositories. So from the Docker container, we need to be able to git clone. And SSH just doesn't like it if the user ID that you are executing the command with doesn't exist in etc password-d. So if you have a solution for that one, then please let me know, because yeah.
Okay.
Hi.
Hi.
So, thank you for the talk. I 100% agree with your talk, so thank you very much for that. I was wondering, one of the earlier points you made was if it's not your core business, you shouldn't even bother with that. I agree with that. My question was, do you have any insights if an enterprise was looking more into buying than building, which products would you recommend that has basically the same feature set as what you managed to do by yourself?
Yeah, so are you asking what might be alternatives to what I've just talked about?
As an alternative, if someone wanted to buy, I was wondering if you had insights on what the market share basically, and which was a good products.
Yeah, so personally, I have some experience with Travis CI, and I definitely see a lot of concepts that now Jenkins is trying to adapt and make default in newer versions of Jenkins that look very much like what Travis CI is doing. I think GitLab, the hosted version, but also the self-hosted version, it has an integrated Docker registry. It has an integrated CI component. I think if you are looking for something like that, then GitLab is really nice.
Thank you very much.
So my question is quite simple. Are you using CI/CD or just CI or just CD?
We are using CI/CD. We are not doing continuous delivery to production yet, but we do it to our several testing environments.
So how do you promote the job from the CI to CD? Is it manual or
no? So one of the testing environments where we push to is we do their rolling release. So the latest version of a certain branch is always going to that testing environment. We don't have any like gate there where we manually say now this is going live.
So how do you manage secrets? Are you using the secrets of Jenkins or an external like Vault-in like HashiCorp Vault?
Yeah, so we are using secrets in Jenkins currently for the story that I told you. The secrets that we have to deal with is SSH keys to be able to, for example, push to a test environment or to do git clones. And these things are managed in Jenkins. And this groovy libraries which I showed you, they make sure that these credentials are then provided, even into the container, so you're able to use them without embedding these secrets in the containers.
Thank you very much. Is there any more questions?
Cool.
So that's fine. The pizza beers party. So thank you very much.